Okay, going over the constructions you should have worked on today in class. The first one was 3AB. So that really just means make a segment that is 3 times the length of segment AB. So I'm going to start by measuring segment AB with my compass. I'm going to put my arc, my compass point at the end of the segment that's given there, and then I'm going to draw 1. So that's 1 AB. So then I'm going to just keep moving over, and I'm going to do it 3 times. And so then starting here, I'm going to label that G, and then these, by the time I get here, that would have been 3 times the original segment AB. So that's our first construction. The next one is CD plus EF. So we measure CD, put our compass point at the end of the line, swing an arc, and then I need to add on EF. Put my compass point where I ended the last one and swing an arc. And this then will be my final answer, which is IJ. So that's adding or multiplying segments, and you can combine the two concepts as well. Constructing a midpoint, all we have to do is create the perpendicular bisector of the segment, so that's our football construction. So I'm going to start by putting my compass point on C, swinging an arc, then put my compass point on D without changing my width, swing another arc, and then I will draw the line through the intersections of the two arcs. And this point right here is the midpoint of CD. So now in step 3, in problem 3, I'm going to construct a line segment that is 2.5 times segment MN that's given here. So I'm going to start by measuring MN. And here's 1 MN. Put the compass point where the arc finishes. Here's 2 MN. And now I have to figure out what half of MN is. So if I just do the football construction on segment MN up here, I'll be able to find my midpoint. Oops. So now, from either endpoint to where the perpendicular bisector intersects the segment, that's half of MN. And now I've made a segment that is 2.5 times MN. So that segment begins here at the end of the line at O, and it finishes here at P. Next example. All right, as a reminder, angle copy. We start by putting our compass point on the vertex of the angle we're copying and swinging an arc. And then we do the same thing over here on our working line. Oops. And then we measure how wide the angle is. We put our compass point on our working line at the intersection of the other arc we created, make an X, and then use our straight edge to connect. And so now we can label this any point will be A prime, B prime, and then C prime. If we wanted to be extra careful, we could make sure that A prime is in the right spot, and I did that okay here. And then C prime, I probably should have made that a little bigger. so I guess C prime should really be over here, but I am not going to get that picky on the quiz. All right, and then you would do the same thing for number 5. You're going to just do an angle copy. And then measure, this is an obtuse angle, so I want to make sure I go far enough. Now I measure how wide my angle over here is, and then I swing and find the intersection of those two lengths. Connect, and then this would be D prime, E prime, F prime. So here's D prime, E prime was already given, and here would be F prime. Last, we're going to construct a parallel line. Now, my preferred method for this one would be an angle copy method. So here's point C. I need to be parallel to this line. They've actually already drawn a transversal for me that I can use. So when we do this, you make sure that you could keep your compass point on your transversal. So we just do an angle copy. So I'm going to copy angle ABC by starting with my compass point on B and swinging an arc, and then I put my compass point on C and I swing an arc. And now I measure how wide the angle is over here by my original arc that I drew, find out how wide it is, put my compass point at the intersection of the arc and my transversal, and swing the arc that way. And now I'm going to connect C to that intersection point, and my lines do look like they're parallel, and that's because what I did was I created two angles here that were congruent. They're corresponding angles, so that should make the lines parallel.